All right, welcome to the video on California 7th Math Standard AF 4.1 or Algebra and Functions 4.1. This is part 1, which is the reason why I have it as 4.1a. It's going to be on equations here, and part 2 will be on inequalities. Like before, I'm going to be working out 4 sample problems. Try to pause the video beforehand and work it out before you try to see me work it out for you. If you're totally clueless on how to do these problems, then by all means, watch the video first, then rewatch it from the beginning, and try to pause the problems and work out the problems before you see me working out the problems for you. Okay, so let's begin. Let's start with this particular expression here. This expression shows -3. This little dot means to multiply. -3 times 3 plus 2. And so the order of operations tells us that we need to actually multiply the -3 times the +3, which gives you a -9 first. And then we're going to add the 2 to it as well. And that gives me a -7. Okay, that's my answer. So -3 times 3 plus the 2 will give me the -7. That's the value of that expression here. Okay, so an equation is basically where they give us the answer. This equal -7 means that this expression here is gonna evaluate into a -7. That's what an equation is. It gives us that gives us the answer. And the unknown is this x here. It's this variable x. A variable means it's an unknown number. And there's one value associated with this x here. Because whatever -3 times this unknown number plus 2, it's going to give me a -7. So there is a one value that x is represented by. Okay, so how do I do these two-step equations here? It's called a two-step because there's 2 operations involved. It's -3 times 2. Oh, I'm sorry, -3 times the variable plus 2. There's multiplying, there's adding. And they give us the answer. To work out these equations, what you need to do is we need to work backwards, actually. And so normally, if we knew what the value of x was, like in the previous problem, we would multiply first, then add, wouldn't we? So in this instance, where we have a variable here, and we can't move on, right? We can actually work backwards, and we can actually take care of this +2 first. And this +2, the thing I'm going to ask you is, what operation is this here? It's addition. We need to actually bring in the negative, or I'm sorry, not the negative, the inverse operation of adding. And the inverse operation of adding is subtracting, isn't it? And what do we need to do? We need to subtract 2 because we want to basically get rid of this +2. We want to be able to cancel this out so that we're left with -3x. And the goal ultimately is to just have the variable only on one side. The goal is to get x equals to the number, because that's what we want to know. We want to know what that x value is to make this equation true. So add 2, we are subtracting 2 to get rid of this here. Let me step back here and kind of go over this here. If I had something like this equation, 5 equals to 5. Isn't this equation true? 5 does equal to 5, right? It does equal to 5. So now, let's say that I took away 2 on one side of the equation, but I did not do so on the other side. What ends up happening? I end up getting a 3 on one side and a 5 on the other. And does this mean that the 3 equals to the 5? By no means. The equality does not hold true. Okay? What do I do so that the equality does remain the same? If I do subtract 2 on one side, I do got to make sure I subtract 2 on the other side. And by doing so, I end up getting a 3 equals to a 3. And here I was able to preserve my equality. So that is what we need to do here. If I'm going to subtract 2 on this side, I got to make sure I subtract 2 on the other side to maintain my equality. And by doing so, what do I end up getting? Notice how the plus 2 and the minus 2 gives you a net value of a 0. So that kind of disappears. And I end up getting negative 3 times the x. Okay. On the other side, I've got negative 7 minus the 2. It means that I basically got 7 negatives. Okay. I've got 2 negatives. And am I actually going to end up getting any positives out of this? No, we're just adding them together. You've got 7 negatives and 2 negatives. That's going to give me a total of negative 9. Okay, 9 negatives. And so there's that. Notice how my operation here is negative 3 multiplied by the x. Okay, negative 3 times the variable. We need to do the inverse operation of multiplying, which is dividing. And so I need to divide. The question is, what do I divide by? Well, the goal is to get x by itself. How do I get rid of this negative 3, this coefficient of a negative 3? I need to divide by what number can I divide the negative 3 by to get rid of this negative 3, meaning that it's going to become a 1. I need to divide by negative 3 because a negative 3 divided by a negative 3 is going to give me a positive 1, and that 1 times the x is going to just give me an x, wouldn't it? So that's what I'm going to do. I'm going to divide by negative 3 here, and that gives me the x. Great. What do I do next? Well, remember, in order for me to preserve this equality, whatever I do to one side, I have to do to the other as well. And so I do need to actually divide by negative 3 here as well. And by doing so, I've got negative 9 divided by negative 3. That's going to give me a value of positive 3. Okay, so that's my answer. That variable of x is really a positive 3. Now, how do I check my work? That's what you need to do. You need to actually check your work here. And these equations are great because you can always check your work. You don't need to wait for the teacher to give you the answer. You can check your work at home or when you're taking a test in class to see if you got the right answer. And how do I do that? You just need to plug in. So I'm basically rewriting the original equation. I've created a little template here. This x is equal to 3. That's what I need to plug in here where the variable of x was. It's a 3. And so I multiply. Negative 3 times 3 gives me a negative 9. So the negative 9 plus the 2 should equal to negative 7. Is that what happens? Well, I've got 2, 3, 4. I got 9 negatives. I've got 2 positives. And we know by our integers that a positive and a negative gives me a 0. A positive and a negative gives me a 0. And so I'm left with how many negatives here? 1, 2, 3, 4, 5, 6, 7. I'm left with negative 7. And is that the same as negative 7 on the other side? You bet. It checks out. Okay? So I know that the positive 3 was my answer here. All right? Let's move on to my next problem here. Number 2. Negative 14 equals to 10 plus 4y. If you haven't done so, you might want to pause the video and write this problem down. Okay, this particular problem might seem a little unfamiliar because now we've got the constant negative 14 on this side by itself. There's an equal sign, and it's showing us 10 plus 4y. It doesn't look the same as the other problem, does it? But it's really the same. All we did was we just kind of flip-flopped this around here. And based on our commutative property, we can actually move these around. You know, when we have 3 plus 7, it's the same as 7 plus 3, isn't it? And so whether we have it as 10 plus 4y or 4y plus 10, they're really the same thing here. Okay? So let's start. The answer was given to us. Normally, if it was just this and we knew what the value of y was, we would multiply first and then we would add the 10 to it afterwards. But since we're working backwards, being that they gave us the answer, we need to take care of this 10 first. And what's the sign in front of this 10? It's a positive. We're assuming it's a positive because there's no indication of a negative sign here. So it's positive 10. How do I get rid of a positive 10? You think of the inverse operation. Positive means to add, so we're looking to subtract. So we're going to subtract 10 on this side. If I subtract 10 on that side, I need to subtract 10 on the other side, and I end up getting a negative 24, okay? Just think you have 14 negatives here, you got 10 negatives there, 14 negatives plus the 10 negatives gives you 24 negatives. And on the other side, you end up having only 4y, okay? Because positive 10 minus 10 gives you 0. So it's basically 0 plus 4y, or just 4y. What's my next step here? Well, what operation is this here? It's 4 times y, which means that we need to divide. What do I divide by? I'm dividing it by negative 4. I'm sorry, I'm dividing by positive 4. I need to divide by positive 4 on the other side as well. What do I end up getting here? Negative divided by a positive gives you a negative 6. And 4 divided by 4 gives you a positive 1. 1 times y gives you the y. So my answer here is y equals to negative 6. Okay, negative 6. How do I check my work? Well, rewrite the problem again. And this time around, we're going to plug in the y spot a negative 6. Here's the negative 6 was the answer. That's what you want to plug in here, negative 6, to check your work here. This is my check. Okay? And so you start with negative 6 times 4 gives you a negative 24. Okay? Gave me that negative 24. So it becomes 10 minus 24. And how do I figure this out? Well, in this portion here, in this box, I've got 10 positives. Okay? In this box here, I've got 24 negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. I've got 24 negatives here. What ends up happening? Well, these 10 positives are going to take out the 10 negatives here. They cancel out to zeros. And so the remaining negatives is my answer, which is negative 14. And so if you look at my original, negative 14 does indeed equal to negative 14 on both sides. It checks out. My answer is indeed negative 6. Okay? Questions? Make sure you write them down and that you'll ask me when we come back to class here. Let's move on to the next problem. Now we got something like this. This actually scares some of my students. This little fraction bar scares them. They don't know what this is sometimes. Well, it is a fraction, but it's also it represents an operation as well. And that operation is division. That little fraction bar represents division. And so it's telling us that an unknown variable, x, an unknown number, divided by a 7, subtracted by the 4 is going to give me a 1. Okay? That's what the problem is. An unknown number divided by the 7 minus 4 gives you a 1. Granted that they gave us the answer, we need to work backwards. And normally we would divide first, then subtract. But since we're working backwards, we're going to take care of the minus 4 first, the subtracting 4. And the subtracting 4 is the same as a negative 4. You're thinking of what is the inverse operation of subtracting? It is adding. And I need to add 4 to get rid of that minus 4. And whatever you do to one side, I do need to do to the other as well. Okay? And so I end up getting just x divided by 7 equals to 5. Okay? How do I get that? Well, the minus 4 plus 4 cancels out to a 0. So that's gone. It's plus. So it's basically x divided by 7 plus 0. We don't need to include the plus 0. So we just got the x divided by 7. It equals to 1 plus 4, which is 5. Okay? Now, what operation is this here? What operation is that? It's dividing. What's the inverse of dividing? It's multiplying. So I need to actually multiply by 7 here. And so let me just kind of rewrite that problem here. What we're going to be doing is we're going to be multiplying by 7. We're going to be multiplying by 7. because whatever you do to one side, you need to do to the other. And when you multiply here by 7, if you remember the rules of your fractions, you place any whole number over 1, you multiply right across, you end up getting a 7x over a 7. Notice how the 7s can actually divide out now. 7 divided by 7 does give you a 1, and it becomes 1 over x, which gives you basically an x. 5 times 7 is a 35, and so my x equals to 35. Okay, that is my answer. X equals to 35. We need to check our work once again. How do I check our work? Write out the problem once again. Okay, and we're going to plug in our answer, which was a 35. We're going to plug that in right up here. Okay, now looking at the problem again, what are we doing? We are 35 divided by 7 has to be first before we subtract by 4. So 35 divided by 7 is really a 5. Okay, so it becomes 5 minus 4 equals to 1. Is that true? Yes, 1. 5 minus 4 is indeed 1, and 1 does equal to 1. And we know that we got the right answer here because it checks out. Okay, are you getting this? I hope so. Let's try one last problem here. I've got 8 equals to y divided by 9 plus 6. What's the two operations here? Dividing and adding. Let's work backwards. Normally we would divide first and add, but since we're working backwards, we're going to take care of the adding first. What's the inverse of adding? The inverse of adding is subtracting. How much do I subtract? How do I get rid of this positive 6? You bring in negative 6. Okay? Whatever you do to one side, you do to the other. I need to make sure I'm subtracting by 6 on this side as well. Okay. So let's do just that. 8 minus 6. Well, you know you got 8 positives. You got 6 negatives. The 6 negatives are going to take out the 6 positives in the positive 8. So you're left with positive 2 equals 2. And the plus 6 and the negative 6 cancels out to a 0. Becomes a plus 0. We can lose that. So we're just left with y divided by 9. Okay? How do I find y divided by 9? Well, this operation here is dividing. What's the inverse of dividing? It's multiplying. So that's what we need to do. We need to multiply. We need to multiply by what, though? We multiply by 9. And so whatever you do to one side, you do to the other. And you end up with 18 as my y, because the 9s divide out into a 1. Okay? And so my answer is 18 here. How do I check my work? The check, you should always check your work here. You rewrite the problem once again. Okay? And what you do is you end up placing the 18, your answer, into where the y was, because that's the whole point of the problem, was to solve for y, wasn't it? So it's 18 divided by 9 plus 6. So we need to divide first here because we've got the unknown number here as an 18. So 18 divided by 9 is a 2. So we're going to add 2 plus the 6. Does that equal to the 8? You bet. It does equal to the 8. So you know that you got the right answer here. Okay, questions on this? Please write them down. I've got some sample problems here for you to do now. You might want to pause at this point. Copy these down. I'm not working these out for you on the video. What you can do, though, is you can actually check your work. Check your work to see if you got them correct, okay? And bring it to class, and you got yourself credit if you can show that you've done all 8 problems here. Alrighty, thank you.